Hey guys, so taking a look at the second drawing, or sorry, it's the third number 3 in the page here on page 40. I've drawn a perspective view of the given steps with the spectator located as shown right here. The picture plane passes through the corner closest to the spectator here. As I said previously, there's the elevation of the object, there's the plan. We are concerned with the plan now. The plan of the object, the plan of the spectator, and the picture plane, when we do find its correct position, will be touching on this front corner. It won't be in front of the object, or it won't be going through the object. It'll be on that corner, which makes it easiest way they can give it. The horizon line is 40 above the ground line, and when the horizon line is 40 above the ground, that means that the height of the spectator is 40 off the ground. The heights of the steps will be taken here from elevation, and then we'll have to just take care on how we apply those on the drawing. We're going to work with the same 4 or 5 initial steps, and you know what, I'm even going to try and keep the same colour scheme here. So from that spectator, we're going to look at the object. We're going to look at the extreme left side, and we're going to look at the extreme right side. So that's our rays of vision, left and right. That's number 1. And I've already taken note of it over here at this left side of the page, so I'm not going to do that again. Second thing is we've looked left, we've looked right, now we want to find the center of our vision. So the CLV, or central line of vision. So I'm going to just bisect that angle. And I'll just make it a fairly long line, because I'm going to set my adjustable based on that. Now, it is handy to have the adjustable for these drawings, rather than trying to do it all with sliding set squares. But look, if you have sliding will work. Now that's my adjustable set to the CLV, or central line of vision, right there. And that central line of vision would be the best position to be aiming your vision at if you wanted to get the most accurate depiction of what this object looks like. The picture plane, which is the position where we want to see what the spectator can see when they look at the object. The picture plane, we're told, goes through the front corner here, and the picture plane is always 90 degrees to the central line of vision. Sticking with the same colour scheme, last time I put the picture plane in there in the dark green. There it is, that's the PP picture plane. And it's going at 90 degrees to the central line of vision. Next, I'd like to find my vanishing points. The vanishing points are the limits of our vision to both sides of the object. So if this object got bigger and bigger, where would the limit of our vision actually be? Where would all of the line of steps, so if they kept going this way, where would my vision start to become a point, basically? And it would become a point when we view parallel to the side of the object. I think in this case, again, the side of the object is just off the T-square there, horizontal. So I'd parallel to one side there, parallel to that side. And then the other side of the object, parallel to that side. And now I've completed everything I can. That's VP1 right there, and that is VP2. I've added in whatever I can into this, which is the plan view. Now I need to take my picture plane, move it down the page, and just drop it down there someplace, and start projecting the actual view of the object and the perspective. So I'm going to take, starting with the vanishing point on one side, then I go to the vanishing point on the other side. I'm going to rub this central line of vision out there, because look, I've set my adjustable now. And I like to start with the ground line whenever I can. Now I know that the ground line is going to go in, and then the horizon line is going to go in. So I've taken the plane that was here, I've moved it down, I'll pick a point to start, which is the ground line. Then I'll just drop it down and I'll have my horizon line up 40. So I'll pick a ground line there, just right there, and I can label that GL. And that's kind of how we often label them, G with an L through. Here's my GL ground line. I'm going to take what they said in the question, that the horizon is 40 mil above the ground, so I'll go up 40. That is the picture horizon line. That is also the height of the spectator. So I have my ground line and my horizon line in. What I also have is the vanishing point, VP1, and this one here, VP2. To begin showing what the object looks like, as this spectator here now, with two separate things going on. We have the plan view of the spectator looking at the object, and we have the true representation of what's happening on that green picture plane as the spectator can see all their detail. We can't draw that here because the plane is standing up and the spectator is viewing through the plane, so we need to move it down the page, drop it down and draw it here instead. First thing we're always looking for is what touches the picture plane. Now on these, say, introductory questions, there's always something touching the picture plane. And what touches it? This point right here touches the picture plane. That is this front edge of the object. If it's touching the picture plane, I can just project it straight down. It sits on the ground and it is, whatever that is it 12 or 15 millimeters tall maybe? It sits on the ground anyway, first off. So it's touching the ground line, and that's the correct true height of it. So it touches the ground line, and that is the true height. So if it's on the picture plane, and if the object sits on the ground, well, we can mark the true height of that edge. And that just gets us something to start with. Now, what I'd like to do next, so that's that height there, I'll call that H1, it's taken from here, H1. Okay. What I'd like to do next is I'd like to start joining back to my vanishing points. And what I'll start looking at is this, so bringing a little bit more meaning to this hopefully. Everything from here going up this way. Every line that goes up that direction will go up towards this vanishing point. So when I want to point on the ground and on the top of the first step, so on the ground and on the top, they're both going up this direction. That means they're both going to go towards this vanishing point. So the point on the ground and the point on the top of the first step will both go back there to the vanishing point. Now depending on the width of the step, if we made this wider, it would appear longer down here. If we put 6 or 7 sets of these steps beside each other, the first one would appear biggest, the next one would be smaller, and so on until there'd be so many beside each other that it just reaches a vanishing point. Similarly, here on this side, I don't really, do I need it? I do, I suppose. I need the bottom of the step going towards the right, going towards this vanishing point here. I need the bottom of the step for sure. Now I do need the top, but just a little portion of it. You know, I don't need all of the top, so maybe I'll just join the vanishing point and just add in a little bit and go very light from there on. What do we see now? Where's the end of the step? Like we can't take a measurement. That wouldn't be true perspective. I can't take this width here and say, well, that's 40, so I'll measure back 40 here. The proportions would look completely wrong. We look at it from the spectator. We view the corner we're looking for. I'm looking for the back corner of the object. We view it, and where our ray of vision hits the picture plane, we project it. We're always concerned about where does our vision hit the picture plane. But we've already done this. We've already viewed the far left hit the picture plane, and now I project that exact point down. And where I project that down, I can change up here to my pin. And now I have the first step done. the riser of that first step down. Now, there's our start. Next, I'm going to take it all the way back to the back of the, so there'll be 1 step, 2, 3, and it'll go back down again to the ground here. I'd like to get that point on the ground first off. So I'm going to view the back point, which I've just already done here in blue, and where our view passes through the picture plane, we project it down. And that means that the back of the steps are going to be there someplace. Now, you shouldn't be using penciling heavy like that, like I am. I'm just trying to show it very clearly on the video, really. That is the line, that is the correct and full line along the ground. I need now to, I'd like to find, that's called the riser. In a stairs, the terminology is riser and the going, okay? The going is length, or we can call it a riser and a tread as well. They're the two. That's just on a side note here in terms of stairs design and stair terminology. The riser and the going is usually what we talk about. Now, I'd like to find where the first step finishes here someplace. So I'll look at it. I'll get that spectator to look at that point, and where that vision hits the picture plane, I project. And that means that I can actually project in line with my projection I already had, vanishing towards point 2. The first step vanishes towards VP2. I can go heavy to there. I don't have to height that first step. The first step vanishes as well towards VP1. And the front of the first step vanishes towards VP2. What you end up getting there is the full surface of that first step. Now, what some people might be wondering is, what about that corner? Could I not have viewed it and projected it down and hit? Yeah, you definitely could. There's loads of different ways to solve perspective questions. There's always different methods that you can bring in, but one of them certainly could be view this point as well. If you felt like it, you could view that point, which is there, project it down, and it'll still land you on, it'll still land you on the very same point here. So you can view as many points as you want, and you can project them, or maybe sometimes you can link up your surfaces to the vanishing points to solve it, to do the job for you. Next, I'd like to get that second step, the height of the second step. Now, where is it? Well, it's up from here, in this corner. It's up here someplace, and it's up from this back corner up here someplace. But that's the one I'd like to get next. And a bit like the last one there, what we have to do is we have to alter the question sometimes. What I'm going to do is this: I'm going to act like as if, I'm going to simplify the question and act like as if it's not what they are saying it is. I'll act like as if I can take the whole surface and extend it out just like that, as if there was no first step there at all, because that makes it very easy. So if that extension is applied to this surface here, let's say, ignore the top of it for now, but if I just blocked the whole thing out like that, what is that? That's the second step here being extended out like that until it hits the picture plane. Anything that hits the picture plane can be taken as a true height. So in my light green here, I've extended out to hit the picture plane. I'm going to take that as my true height. I bring that down, that's H2 now, and onto the center line here, and mark. Okay, that is my H2. I've just taken from above and mark it in there as H2 from the ground up. And now, what way does it go? Well, it goes back to the right towards the vanishing point number 2. And that extended height, vanishes back, and is the true height here. Now you'll notice that, let's say, the height of the second step is actually about 15 millimeters, and on the picture plane it's 15, but back here it's closer to about 12. And that is the true height as it appears on the picture plane there. That's the actual representation that we need from the picture plane. I should be just using my adjustable one. So I'm going to project up until I hit that height line. That's the correct point. I'm going to vanish it back the opposite way until I hit the back of the step there. Lucky enough for me, I did that fairly well guessed when I heavied up my line. Next, I need to get the back of the step here someplace and build it up to the next one. I need to get the front of the step as well. No, or sorry, the left side there. I can vanish that left side. And this way, I'm going to view this point now. So I'll view and project. That's someplace around here. Up for the next step. I can heavy in the portion of the second step there. I can also vanish it towards VP1 until it hits the back, the corresponding edge here. I'd like to just verify, because this is getting so small, I'd like to verify that I have that point correct back here. And the best way to verify that very quickly is join and project. I think that moved a little bit there. Yeah. Just a little bit off in my accuracy on that one. I need to check that again. Yeah. I can see it now. It was a little bit off when I laid that down, and I thought that when I looked at it. So I'm going to go doing too much rubbing out there to look fine after. So if you're ever in doubt like that, I thought I might have joined that a little bit inaccurately there. Just join, so view the point and project. That gets me to the top of the next step. The third step up is going to work the same way as the previous ones. I'll just do this in orange here. And it's all part of an extended surface again. So we can take full surface, which I did light green last time, I'll do orange this time, and we can just take the top step, extend it out as if it's a full size block there. That is H3 then, the height of the top one there. That was H2 there along the way. If I did do that extension from this top step here, it would just basically be extending out just like that from the top step, pushing out and extending onto hit the plane, giving me a point there at the front again that I can use a true height. And I can take height number 3 from the point that we extended out and hit. Now, just as a little point to note, I can also extend down this way, hit the plane, bring it down onto the ground line, mark the correct height and vanish. So you can extend one way or the other. It is completely up to yourself. And we will get onto scenarios where we'll want to extend out heights going this way as well. Okay, for now I can keep them all coming in towards the center. That is height 3. Take the height 3 and I'll mark it as a true height because we've extended it onto the plane right there. That is H3. And I'm going to vanish that. So I've extended it this way. I'm going to vanish back again, back towards VP2. And that gets me the top of the last step. So up to hit, back down, back down. The only portion I can heavy in for now is actually here to here. That is the top step though. I hope we you might have noticed, if maybe you were just jumping on ahead of me or something, you might have noticed that we're just after going above the horizon line. Okay, and once we go above the horizon line, we were able to see the top of this step, and a lot of it, because it was well down below our horizon line here. And as we get closer to the horizon line, we're not seeing the steps quite as large. And once we go up over the horizon line, well, it's above us. It's then above us, and we can't see the top of it at all. Now I'll just finish off that step there. And as I said, we cannot possibly see the top of the shape this time, because it's just gone above the horizon line for us. There's another example done. 3 heights marked on this front point, or this front projection here. 3 heights marked all on that point. I'm going to just show you one more thing, okay? And this is again a complete extra dropped in here, but it will stand to you for upcoming questions. I'll show you something else, right? I did say for that top step that we could project it either way, and now that the drawing is finished, watch this, okay? We can project the drawing either way. So I could take the heights of any surface and extend it down on to hit the plane. When it's on the plane, at that position, it's a true height. That angle, oh wow, that angle is so wrong. Sorry now, I just have to get rid of that very quickly before anyone does see it. Check my projections here again. Yeah, that's more like it. So when I extend down and hit the plane, I have a projection there, and on that projection I can take the true height of that third step. Now I can do this, right? On that third step I'm getting one height and the second height. So for example, just to link my view so that I'm putting the compass down correctly. For example, and the drawing is finished, of course. This is all a little bonus here now. That's the height of the second step, which is along this edge here as well. That's the height of the second step. And that's the height of the third step. I can take them in that position as true heights. So the extended piece, where that step was extended out to hit here, that extension plane is actually here. Watch the way it all matches up. To here and to here. So what has actually happened there, by extending out this direction, all we've actually done is created a planar extension. So we've taken a plane and we've extended, and we've marked the true height at the position where that plane hits the picture plane. And there in orange is what we've actually done. What happens in orange here is this. Extending the plane out until it hits the picture plane results in exactly this. That orange line right there, this guy, is on picture plane. That touches the picture plane. And because it does, because we extended that out and hit the picture plane, we can bring it down and we can mark true height 1 and true height 2. So there's just a little extra, and hopefully a little graphic to kind of explains what's happening as well. And once again, if it extends down, hits this picture plane, or hits the picture plane here, we're looking up and down. Where does everything go in that direction join to? They join to vanishing point 1. So when I brought it down to hit the picture plane, I joined this to vanishing point 1. Now there's going to be loads of examples where we're going to be joining to the second vanishing point, and so much you can possibly do here. To give some context as well, what happened up here in green, for example, this extension going out this direction, extending out from the second step, so first to second until it hit, is actually right there. It's a planar extension that we can see right there. So extending a plane, and the reason we do these extensions is because it stretches that plane out, or stretches a particular area out until you hit the picture plane, allowing us to mark a true height. Hopefully that video has helped. Two nice little introductory questions there for you to work on, and hope you're enjoying Perspective so far.